So today you'll learn how to calculate molarity, percent of solution by volume, and by mass, and ppm. So molarity, the concentration of a solution is the measure of amount of a solute that is dissolved in a given quantity of solvent. So a diluted solution is one that contains a small amount of solute, and a concentrated solution is the one that contains the large amount of solute. So, how do you calculate the molarity of a solution? So, molarity is the number of moles of solute dissolved in 1 liter of solution. So, to calculate the molarity of the solution, first you must divide the moles of solute by the volume of the solution. So, in our previous lessons, na-discuss naman natin on how to compute the moles of a certain substance. So, same thing sa stoichiometry, you have first to determine the moles of solute divided by the liter of solution. So, that is molarity. So, in laboratory preparation naman, for example, to make a 0.5 molar of solution or a solution that contains a 0.5 molarity of concentration. So first, you have to add 0.5 moles of solute to a liter of volumetric flask half filled with distilled water. So, volumetric flask kasi yung glassware na ginagamit sa preparation of solution because it has the most accurate one. So, bakit half-filled? So, kasi kailangan mo pang i-dissolve yung solute mo. So, after putting the certain amount of moles in a volumetric flask, you have to swirl the flask carefully, dissolve the solute, and fill the flask with water exactly to the 1 liter mark. So, dito sa volumetric flask, meron siyang line dyan na nag-indicate kung hanggang saan lang yung dapat ilagay na water or na solvent to attain the exact concentration of the solution that you are going to prepare. So, in calculating the molarity of solution, so for example, intravenous saline solutions are often administered to patients in the hospital. So, one saline solution contains 0.9 grams of NaCl in exactly 100 ml of solution. So, what is the molarity of solution? So, para hindi kayo malito, first, you have to jot down or to list the knowns and the unknowns. So, given the problem, first, sabi, it contains 0.9 grams of NaCl or the salt. So, solution concentration, 0.9 grams of NaCl per 100 ml of solution. So, malalaman natin from our periodic table that the molar mass of NaCl or sodium chloride is 58.5 grams per mole. So, those are the knowns based on the question from knowns given by the question. So, ano naman yung unknown? Para hindi din kayo malito, I suggest you should jot down and list also the unknown. So, solute concentration, yun yung hinahanap. What is the molarity of the solution? So, the unknown is the solute concentration. So, first, convert the concentration from grams per 100 ml to mole per liter. So, same formula or same process by stoichiometry. So, the sequence is gram per 100 ml to mole per 100 ml to mole per liter. Mole per liter kasi yun yung unit ng molarity. So, dapat magka-come up kayo sa mole per liter. So, to calculate, use the molar mass to convert grams of sodium chloride per 100 ml to mole of sodium chloride per 100 ml. Then use the conversion factor between milliliters to liters to convert mole per liter, which is molarity. So, the solution of concentration is equal to 0.9 gram of NaCl per 100 ml of solution times 1 mole of NaCl per 58.5 grams of NaCl. So, saan ulit siya galing? Sa molar mass ng NaCl galing sa periodic table. And then, conversion factor, which is, there is 1,000 ml per 1 liter. So, you'll come up with 0.15 mole per liters or 0.15 molar. So, yung malaking M, molar yon. Mole per liter or molar is accepted. So, sa tingin mo ba tama yung sagot mo? So, the answer should be less than 1 molar because the concentration of 0.9 grams per 100 ml is the same as 9 grams per 1 liter or 1,000 ml. And 9 grams is less than 1 mole of sodium chloride. So, the answer is correctly expressed in two significant figures. So, this is a practice problem. So, you can compute this or do this on your own and put it in your learning log. So, finding the moles of solute in a solution. So, household laundry bleach is a dilute aqueous solution of sodium hypochlorite or NaClO. How many moles of solute are present in 1.5 liters of 0.7 molar sodium hypochlorite? So, katulad kanina, first list down the knowns and the unknowns. So, yung mga alam natin or yung mga given sa problem is, the volume of solution is 1.5 liters. The solution concentration is 0.7 molar sodium hypochlorite. And ang hinahanap natin is yung moles ng solute. And alam natin na moles of solute is equals to the molarity times the liter. So, makikita nyo naman dito, moles ng solute, so, molarity is equal to mole per liter. And para makuha mo yung solute, you have to multiply it by the liter of solution. So, here, makakancel yung liter, and then, matitira ka na lang ng mole. So, yun naman yung hinahanap natin. So, you'll obtain the mole of solute. So, the conversion is volume of solution to moles of solute. Molarity has the units of mole per liter and the conversion factor between moles of solute and volume of solution. So, multiply by the given volume by the molarity expressed in mole per liter. So, to calculate and to solve for unknown, katulad ng sinabi ko kanina and yung binigay natin na formula. So, moles of solute is equals to molarity times the liter of solution. So, 0.7 mole of sodium hypochlorite per liter times 1.5 liter would be equal to 1.1 mole of sodium hypochlorite. So, sa tingin nyo ba tama yung solution or yung sagot? So, the answer should be greater than 1 mole but less than 1.5 mole because the solution concentration is less than 0.7 molar and the volume is less than 2 liters. So, the answer is correctly expressed in two significant figures. So, another practice question. Lahat ng practice question na madadaanan natin should be put and answered in your learning log. So, in making dilutions, what effect does dilution have on the total moles of solute in a solution? Diluting a solution reduces the number of moles per solute per unit of volume, but the total number of moles of solute in the solution does not change. So in making dilutions, the total number of moles of solute remains unchanged upon dilution. So you can write this equation. The moles of solute is equal to the molarity times the volume of initial solution and the molarity and volume of diluted solution. So, M1 yung molarity ng initial solution and V1 yung volume ng initial solution. And yung M2 naman is the molarity of the diluted solution and V2 is the volume of the diluted solution. So, as you can see, yung solution A is yung concentrated solution natin. So, makikita nyo yung blue, yung particles ng solute. So, mas marami siya. Compare dito sa diluted solution. So, sa diluted solution naman, mas dumami yung solvent kasi nagdagdag ka ng water. So, from approximately 75 ml to 350 ml. So, nagdagdag ka ng water, syempre, dadami yung moles ng water. Pero, yung moles ng solute, same pa rin. Pero, dumami sa diluted solution yung moles ng water or ng solvent. So, again, yung moles ng solute hindi nagbabago. Ang nagbabago lang kapag na-dilute na, dumadami yung moles ng solvent natin kaya bumababa yung concentration ng solute. Okay? So, in laboratory practices naman, how are you going to make dilutions? So, for example, to prepare 100 ml of 0.4 molar MgSO4 from the stock solution of 2 molar. So, ibig sabihin meron ka ng previously prepared na 2 molar na MgSO4. So, here, a student first measures 20 ml of the stock solution with 20 ml pipette. So, here's the pipette. Then, she transferred the 20 ml into 100 ml volumetric flask. And then, she carefully added water to the mark to make 100 ml of solution. So, here are the volumetric measuring devices that we are using in the laboratory. So, here is the pipette. So, yung mga volumetric measuring devices natin, yun yung mga pinaka-accurate sa lahat. So, Hindi lang dahil yung beaker natin ay may nakalagay na 200 ml is, yun na yung pinakatamang measurement. So, ang pinaka-accurate na measurement na ma-attain natin is kapag gumamit tayo ng volumetric measuring devices, which are pipette, volumetric flask, graduated cylinder, and burette. So, sa mga glasswares natin, i-observe nyo. Yung may mga glasswares natin, may nakalagay na TC tsaka TD. So, ibig sabihin ng TC, to contain. Hindi siya dapat ginagamit na pang-measure. Katulad nung Erlenmeyer, hindi siya ginagamit pang-transfer, pang-contain lang siya. So, TC yung nakalagay sa kanya. Pero yung mga volumetric measuring devices natin like graduated cylinder, pipette, to deliver yung nakalagay sa kanila. Kasi kapag may naiwan na isang patak dun sa tip ng glassware mo, ibig sabihin, counted na yon sa, for example, 20 ml siya. Nakabilang na yung 20 ml doon. Kasama na yung patak na yun doon. Kaya, volumetric devices are the most accurate. So, in preparing a diluted solution, here's a problem. How many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 ml of aqueous solution of 0.4 molar magnesium sulfate. So, first, list the knowns and the unknowns. So, knowns are the molarity of the concentrated solution, which is 2 molar MgSO4, the diluted concentration, which is 0.4 molar magnesium sulfate, and the volume of the concentrated solution, 100 ml of 0.4 molar magnesium sulfate. So, ang hinahanap natin is the volume, yung V2 pala, yung diluted. So, hinahanap natin yung ilang volume ng concentrated yung kukuhanin natin dapat to produce 100 ml ng 0.4 magnesium sulfate. So, from our previous lesson, previous slides, we know I have given the formula M1 times V1 would be equal to M2 times V2. So, solving yields for V1 would be equals to M2 times V2 divided by M1. So, 0.4 molar times 100 ml divided by the 2 molar would yield to 20 ml. So, ito yung pinrepare ng student dun sa previous slide natin. Tama ba na 20 ml yung kinuha niya from the concentrated solution? So, di ba nagpipet siya ng 20 ml kanina? So, na-compute natin na tama naman yung ginawa niya and yung method ng preparation na ginawa niya sa dilution. So, 20 ml of the initial solution must be diluted by adding enough water to increase the volume of 100 ml. So, sa tingin niyo tama? The concentration of the initial solution is 5 times larger than the concentration of the diluted solution because the moles of the solute in each solution are the same. So the volume of the solution to be diluted should be 1/5 from the final volume of the diluted solution. So the answer is correct. So, another practice question that you should add on your learning log. So, percent solutions. So, percent solutions. What are two ways to express the percent concentration in a solution? The concentration of a solution in percent can be expressed in two ways. As the ratio of volume of the solute to volume of the solution, or as the ratio of the mass of the solute to the mass of the solution. So, concentration in percent volume per volume. So, volume or percent volume per volume would be equals to volume of solute divided by the volume of solution multiplied by 100. So, for example, isopropyl alcohol or 2-propanol is sold as 91% solution. This solution consists of 91 ml of isopropyl alcohol mixed with enough water to make 100% of solution. So, remember nyo ba na nung pandemic, we had shortage of 70% alcohol, yeah. Rubbing alcohol. So, may mga nagbebenta online, sinasabi nila na kapag pinagsama mo daw yung dalawang 70% na alcohol, you'll produce 140% of alcohol. So, sa tingin nyo ba tama yon? So, the answer to that question could be answered by this lesson. So, we'll explain that later. So, calculating percent volume per volume. What is the percent by volume of ethanol in the final solution when 85 ml of ethanol is diluted to a volume of 250 ml of water? So again, first list the knowns and the unknowns. So from the problem, ang binigay is volume of ethanol, which is 85 ml. Then volume of solution, 250 ml. And we're looking for the percent of ethanol by volume. So, given the formula, percent by volume would be equal to volume of solute per volume of solution times 100. So, substitute the known values into equation and solve. So, percent volume per volume, 85 ml of ethanol divided by 250 ml of water times 100 would give to 34% of ethanol. So the volume of solute is about 1/3 of the volume of the solution. So the answer is reasonable. The answer is correctly expressed in two significant figures. So kanina yung question natin na if you add 70% of alcohol by another 70% of alcohol, the answer should be, using your knowledge in molarity, 70% pa din yung makukuha mo. So, sige, kung gusto nyo, try nyo i-compute. So, another practice problem. So, percent solutions ng concentration expressed in percent mass per mass. So, kanina, volume per volume. Now, mass per mass naman. So, percent by mass would equal to mass of solute divided by mass of solution times 100. So, I have given here another example naman. Baka kasi malito kayo. So, sabi natin, percent by mass is mass of solute per mass of solution. And solution is equivalent to the solute plus solvent. So, yung solution, yung pinagsama na solute tsaka na solvent. So, kapag magkahiwalay siyang binigay, kailangan mo muna siyang i-add. So, percent by mass could also be expressed by mass of solute per mass of solute plus mass of solvent times 100. So, ganun din sa volume. So, kapag kulang yung volume na binigay, hindi binigay yung total volume of the solution, i-add nyo lang siya. So, that would be the mass or the volume of the solution. So, Ito times nyo siya sa 100 after nyo i-divide yung dalawa, and you'll get the percent by mass. So I have given here another example. A sample of 0.92 grams of potassium chloride or KCl is dissolved in 54.6 grams of water. What is the percent by mass of KCl in the solution? So, as you can see here, diba, hindi binigay yung total mass ng kabuuan. So, you have to add here first. So, as we have discussed earlier, percent by mass is equal to the mass of solute divided by the mass of solution times 100. So, mass of solute, 0.892 grams of KCl divided by the mass of KCl plus the mass of water in grams times 100, and that is 1.61%. So, next is mole fraction. The mole fraction of a component of a solution, for example, component A is written as XA, is defined as mole fraction of component A is XA equals to moles of a component A divided by the total number of moles of all components, or the sum of moles of all the components. So I have here a sample question for mole fraction. So given here, 0.1 mole of NaCl or sodium chloride is dissolved into 100 grams of pure water or H2O. What is the mole fraction of NaCl? So first, list down the known. So we have given here mole of solute or the NaCl, which is 0.1 mole, and the mass of the solvent, which is the water, 100 grams. So we have tackled earlier that mole X, or the mole fraction, is equals to the moles of the components divided by the total moles of the solution. So first, we have to compute the moles of the solvent. That would be equals to the mass of the solvent divided by the molar mass of the solvent. So, given 100 grams of solvent divided by molar mass of solvent. So, bakit 2 plus 16? So, 2 kasi 1 yung molar mass ng hydrogen. So, times 2 kasi H2O plus 16 is the molar mass of the oxygen. That would give you 2 plus 16, 18 gram per mole. So, 100 grams divided by 18 gram per mole would yield to 5.56 mole. So, the mole fraction of sodium chloride naman. Mole fraction of sodium chloride would be equal to the moles of NaCl divided by the total moles of the solution. So, 0.1 mole of NaCl divided by sa na-compute natin kaninang mole ng solvent plus mole ng NaCl would give you 0.18. I mean 0.018. So, yun na yung final answer ng mole fraction ng sodium chloride. So, next naman is molality, which is denoted as the small letter m. So, huwag kayong malilito. Kanina yung molarity, big letter M, and then yung molality naman is small letter m, is the number of moles of solute dissolved in 1 kilogram or 1,000 gram of solvent. So, molality is equals to the moles of solute divided by the mass of solvent in kilogram. So, for example here, calculate the molality of sulfuric acid solution containing and 24.4 gram of sulfuric acid and 198 grams of water. The molar mass, which is makukuha nyo din naman sa periodic table of sulfuric acid, is 98.09 grams. So, from the moles of sulfuric acid or H2SO4 given 24.4 grams of H2O times 1 mole of H2SO4 divided by 98.09 grams or yung molar mass. So, nasa baba yung grams para makancel siya and para makuha mo yung mole. So, nakuha is 0.249 mole of H2SO4. So, since nakuha mo na yung moles, sabi natin, molality is equals to the moles of solute divided by the kilogram of the solvent. So, 0.249 moles of H2SO4 divided by 0.198 kilograms. So, bakit siya 0.198 kilogram? So, kinonvert na natin yung grams into kilograms. So, 198 grams of water is equals to 0.198 kilograms of H2SO4. 198 grams is equals to 0.18 kilograms of H2SO4, and that would yield to 1.26 molal. So, kanina, sa molarity, molar, yung malaking M. And then, sa molality naman, molal, yung maliit na letter M. So, for the next question naman, calculate the molality of a 35.4% by mass aqueous solution of phosphoric acid or H3PO4. The molar mass of phosphoric acid is 97.99 grams. So first, convert muna natin yung liters to ml. So 1 liter is equal to 100 ml of solution times yung given na density, which is 0.976 gram per ml of solution. So may nakuha 976 grams. So, to get the mass of water, 976 grams minus mass of solute. So, to get the mass of solute, 246 moles of methanol times the molar mass of methanol given kanina. So, you'll get in 898 grams. So, bakit sa tingin nyo, minus natin to? So, di ba ang definition ng molality is moles of solute divided by kilogram of solvent. So, may nakuha tayong mass ng solution. Pero ang kailangan natin is yung kilograms ng solvent. Kaya, minus natin siya. So, mass ng solution minus ng mass ng solute is equal to the mass of H2O or the mass of the solvent. So, divide lang natin dahil ang sabi nga natin, molality is equals to the moles of solute, which is the methanol, divided by the kilogram of the solvent, which is the water. So, 2.45 mole of methanol divided by 0.898 kilograms of water is equal to 2.76 molal. So, to get the moles of phosphoric acid, so given kanina yung mass, which is 35.4 grams ng phosphoric acid. So, divide natin sa molar mass ng phosphoric acid to cancel the grams and you'll get the moles. So, ang nakuha natin is 0.361 mole of phosphoric acid. So, again, molality is equals to the mole of solute divided by the kilogram of solvent. So, kanina na-compute natin yung moles ng phosphoric acid which is 0.61 mole divided by the given 0.0646 kilograms of water and you'll get 5.59 molal. So that ends the discussion of the concentrations of solution. So, may mga nilagay ako dito na mini quiz na idadagdag nyo sa inyong learning log. So, here are the question. You can pause the video naman. So, here are the question. Mamimili lang kayo kung ano yung sa tingin nyo na sagot dito. So, that's the first question. Second, third, fourth, fifth. So, our next topic would be colligative properties. So, I'll review from our previous lesson. So, we have known the formula of mole fraction, molality, and molarity. So, colligative properties are properties that depend only on the number of solute particles in solution and not on the nature of the solute particles. So these properties are bound together by a common origin. They all depend on the number of solute particles present, regardless whether they are atoms, ions, or molecules. So the colligative properties are vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So vapor pressure lowering. The pressure exerted by the gas in equilibrium with a solid or a liquid in enclosed container at a given temperature is called the vapor pressure. So an enclosed container at a certain temperature. If a solute is non-volatile or hindi yung mabilis mag-evaporate, the vapor pressure of its solution is always less than the pure solvent. Thus, the relationship between solution vapor pressure and solvent vapor pressure depends on the concentration of the solute in the solution. Kanina, sinabi natin, regardless kung atoms sila, or molecules, or compounds, nakadepende pa rin doon sa dami ng substance. So, Raoult's law states that the vapor pressure lowering is directly proportional to the mole fraction of the solvent and the vapor pressure of the solvent. So, to compute the moles of water, we have to divide the 500 grams of water given here by the molar mass of water, which is 18 gram per mole, and you'll get 27.7 mole of water. And to compute the moles of glucose, given here, 50 grams of glucose divided by the molar mass of glucose is 0.277 moles of glucose. So, compute the mole fraction. So, moles of solvent divided by the moles of all the components would give you 0.99. So we can now compute the vapor pressure of the whole solution. So Basel-Raoult's law, P solution times mole fraction of the solvent times the vapor pressure of the solvent. So mole fraction of the solvent, yung na-compute natin kanina, and given 47.1 torr ng solvent. So the vapor pressure of the solution is 46.63 torr. So, ang sinasabi lang dito is kapag nagdagdag ka ng component, is tumataas yung boiling point niya. For example, nag-init ka ng tubig. Anong boiling point ng water? 100 degrees Celsius. Pero kapag yung water nilagyan mo na ng coffee, saka mo ininit, ulit kunwari lumamig na yung coffee mo, hindi na 100 degrees Celsius yung boiling point niya. So, mas mataas na doon. So, there is an elevation. So, yung difference ng boiling point ng pure na water plus yung coffee, yun yung itinaas. So, yun yung difference, and that is the boiling point elevation. So, katulad dito, nakikita nyo dito sa chart sa gilid, itong solid line is yung here, yung boiling point ng pure water. So, pero kapag may dinagdag ka na component, may shift to the right. So, ito na yung boiling point ng solution kapag may dinagdag ka. So, yung difference ng pure water dun sa solution, yung difference nun, itong line na to, yun yung tinatawag na boiling point elevation. So next is freezing point depression. Freezing involves the transition from a disordered state into ordered state. So, kapag, for example, sa water ulit, so yung liquid form ng water is hindi ordered yung molecules niya, or so kalat-kalat, kaya nga siya liquid. So, kapag nag-freeze na siya, naging solid na siya, mas compact yung, or mas tabi-tabi yung molecules, so mas ordered. Meron silang sariling place. So, for this to happen, energy must be removed from the system. Because the solution has greater disorder than the solvent, more energy needs to be removed from it to create order, in that case of the pure solvent. Therefore, the solution has lower freezing point than its solvent. The freezing point depression is defined as the freezing point of the pure solvent minus the freezing point of the solution. So, the freezing point depression is directly proportional to the molal freezing point depression constant. So, may chart yan, given naman yan lagi. And the molality of the solution. So, for example naman, sa coffee and sa water ulit. Kapag gusto mo ng coffee ice cream, so, alam naman natin na yung freezing point ng water is 0 degrees Celsius. Pero kung mag-create ka ng ice cream, coffee ice cream, so, papalamigin mo yung coffee, so, water plus coffee, hindi na 0 degrees Celsius yung freezing point na. So, here na. So, makikita nyo naman dito, ito yung freezing point ng water. Here. Tapos, ito na yung freezing point ng solution. So, the difference here, mas mahirap na siyang I-freeze kasi meron ng kaagaw yung water na molecule. So, mas marami ng molecules doon, mas mahirap na siyang patigasin or ilagay sa order yung atoms. Kaya meron kang difference na temperature, and that is called the freezing point depression. So, ano ba yung importance ng freezing point depression? So, sa mga countries na merong winter season, so nagdadagdag sila ng ethylene glycol sa mga gasolina para hindi agad mag-freeze yung gasolina. So, sa airplane technologies naman, yung pagtanggal ng ice or de-icing ng airplane is nakabase rin sa freezing point depression. So, ito yung table na sinasabi ko kanina, yung table ng molar boiling point elevation and freezing point depression. So, sabi ko kanina, constant yon, and ibibigay naman to kapag sa exam. So, hindi nyo siya kailangang kabisaduhin. So, to calculate the freezing point ng solution, so alam naman natin na yung freezing point ng water is 0 degrees Celsius. So, i-minus lang natin yung na-compute natin na freezing point depression. So, 0 minus 7.79 degrees Celsius. So, yung bagong freezing point ng buong solution, which is ethylene glycol plus water, is negative 7.79 degrees Celsius. So, the last colligative property that we are going to discuss is osmotic pressure. Osmosis is defined as the selective passage of solvent molecules through a porous membrane from dilute solution to a more concentrated one. The osmotic pressure of a solution is the pressure difference needed to stop the flow of solvent across the semi-permeable membrane, which is this here. So, the osmotic pressure of a solution is proportional to the molar concentration of solute particles in solution. So, pi yung osmotic pressure. So, yeah. Molarity ng solution naman yung kailangan natin. So, kanina sa freezing point depression and sa boiling point elevation, molality yung kailangan natin to compute. Sa osmotic pressure naman, molarity. So, R is a gas constant. So, constant to. Hindi siya kailangang ibigay. Laging yun constant yung value niya. T is yung temperature. So, this is an example of osmosis. So, this is what are RBCs, or red blood cells. So, hypotonic. So, yun yung may low concentration ng fluid. And hypertonic has higher concentration naman ng fluid. And then yung isotonic, yun yung same or similar concentrations ng fluid. So, alaman naman natin na, sabi nga natin, yung osmosis nangyayari if it pass through a semi-permeable membrane. So, yung membrane dun sa bloodstreams, yung sa red blood cells, so, yung water, nagtatravel siya depending dun sa higher concentration and sa lower concentration. So, sample problem. The average osmotic pressure of seawater is about 30 atmosphere at 25 degrees Celsius. Calculate the molar concentration of an aqueous solution of sucrose that is isotonic with seawater. So, we know that pi is equal to MRT, or the osmotic pressure is equal to the molar concentration times the gas constant times the temperature. But since ang hinahanap is the molar concentration, So, given yung osmotic pressure, R, which is gas constant, and temperature, ang hinahanap is yung molar concentration. So, to find the molar concentration, we have to manipulate the formula. So, para mahanap natin yung molar concentration, we have to divide the osmotic pressure of seawater, divide it to the gas constant and the temperature. So, osmotic pressure, 30 atmosphere, divided by the gas constant, which is 0.0821. Ang unit is liter atmosphere per mole Kelvin. So, bakit natin inad sa 273? Kasi yung 25 degrees Celsius, kinonvert natin sa Kelvin. So, ma'am, bakit kailangan po nating i-divide sa Kelvin? Kasi, naka-Kelvin yung unit ng gas constant. So, to cancel, magiging Kelvin na tong unit ng temperature since yung degree Celsius, kinonvert natin siya sa Kelvin. So, kapag minultiply, makakancel to. And then, makakancel din yung unit ng temperature. And then, matitira is mole per liter. Kasi akyat yung mole, may iwan sa baba yung liter. So, the answer is 1.23 mole per liter or 1.23 molar. So thank you. That ends our lesson for the concentration of solutions and colligative properties.